Hey guys, welcome back. You're in 2.3a phase change notes. Today you're going to need two papers. I know it sounds weird. One of them is going to say, where's our camera? There we go. It's going to say 2.3a phase change notes number one. Problem is that there was so much information that I had to have a second sheet. So please make sure you get your second sheet as well. All right, get rid of my face so it's easier to listen to. All right, so why couldn't the astronaut book a room on the moon? Because it was full. Full moon, we just had one. All right, here we go. So your goal in these notes, you're looking at developing models to explain essentially what happens when you add thermal energy and what happens when you remove thermal energy. So kind of like looking at it like you've got ice. What is the process that's taking place that we can't see with our eyes on the macro scale? On the micro scale, what's happening when ice turns into water? And what's happening when water turns into ice? So that's essentially what it is. This is Lake Tioga. Water is always used in science because it's one of the few substances on Earth that you frequently observe in the three states of matter. You really don't observe. You may see gold in the solid, but you really don't see gold in the liquid very often. You may see oxygen. You may have it in the gas form, but you rarely see it in the liquid form unless you're in the field of science. So we're going to look at what causes water to change from one state of matter to the other. All right. Your first piece of notes on phase change. You can go ahead and pause here. This is the definition of phase change is going from one state of matter to another. When a solid changes to a gas, when a solid changes to a liquid, liquid goes to a solid, and on and on. And sometimes some of the matter can skip. For example, dry ice, which is carbon dioxide, dry ice goes from a solid to a gas. There's no liquid form. It skips that phase. So the state of matter depends on the molecular motion. And you're going to write this one in the second box right over here. Right, there we go. I'm still getting used to this right here. Oh, there we go, making you dizzy. Right over here, the second box. The state of matter depends on molecular motion. So you know that solids, as you can see, are close together, touching and vibrating, which makes them a solid. That's why it's hard to walk through a wall. As the thermal energy, as you add energy, the particles start moving more. You can see the space is increased and you can see their motion lines. And as they turn into a gas, same thing. More energy leads to more space and faster particle moving. Just like if you remove the energy, and you usually don't say remove energy, you say put it in the freezer, put it in the refrigerator, let it cool off, you're really removing energy. All right, our first one. So melting. So melting is the change in a state from a solid to a liquid, whether up here it's from gold, solid gold going into liquid gold to make a new type of jewelry, or whether it's ice going from a solid to a liquid form. The thermal energy increases, and you'll add this to your paper, and the motion increases as well, the particle motion. So once you add energy, everything starts moving. All right. So right now what I'd like you to do is I'd like you to pause the video and I'd like you to add some motion lines over off the right because you can see the solid is melting into a liquid. And during this process, the particles speed up, they move further away from each other. And scientifically, what's happening is they gain enough energy to break away from each other. And that's really where a solid becomes a liquid, and even really where a liquid becomes a gas. When there's enough energy to break away, the bonds break, and then the particles separate, and then they change the state of matter. And the melting point is the temperature at which a substance melts. For example, gold could be around 2000 degrees. Silver is going to have a different melting point. Ice is going to have a different melting point than plastic. You can even look up melting points on your own to see the different stages of melting points. All right. Down at the bottom of the page, we're going to talk about vaporization. And vaporization is the change in state from a liquid to a gas. Believe it or not, you've seen this. You see it all the time. When you have hot tea or hot cocoa or hot soup, the steam that you see coming off is really the process of vaporization. The liquid is becoming a vapor. The liquid is changing to a gas. The particles are bouncing around so much that they finally break the bonds and separate, and they change from a liquid into a gas. Moving over to your vaporization. There we go. So once they move, once they separate far enough, they overcome the forces that are holding them in a liquid state and they become gas particles. Now, boiling is something that you also see as well. And boiling is vaporization, but it's vaporization that occurs within the liquid. Because when you look at this top, this pot here that's boiling, vaporization, we just learned, happens when a liquid turns to a gas. Well, it can happen at the top, but it can also happen within. And those are the bubbles you see when the heat source is so much that the thermal energy is and the kinetic energy is so high that the water will turn to gas inside the liquid. And the gas does what? It wants to escape. It's lighter. And so it floats up, it's forced up to the top, and then it escapes out of the top. Boiling point is the temperature at which a liquid boils, similar to where melting point is where an object melts. Liquids also have a boiling point, and all matter, they all have different boiling points. Our last one here is of evaporation, and evaporation is vaporization. So it's when the liquid turns to a gas, but it takes place on the surface. So you've got vaporization, which is really just the liquid turning to a gas, but it can happen in two different places. It can happen on top of the liquid and it can happen within the liquid. And I know it's a lot of terms. You're just getting them for the first time, but we'll be practicing. Don't worry. Hope this gives you an idea of when you have a solid, if you add thermal energy, you get a liquid. If you add thermal energy, you get a gas. And if you add enough energy to gases, mostly out in space, away from the world, you get the fourth type of matter, that's plasmas. And while plasma does occur on Earth a little bit, it's mostly in the universe, mostly in stars. All right, guys, that's it for today. Enjoy.